Thank you.
Thank you. How's everyone feeling after lunch? Tired? No? Yeah. Good. All right. Quick question. How many of you are red teamers, pen testers, offensive oriented? Hey, raise your hands up. I see hands slowly coming up. All right.
Good turn up.
And then blue team and... Okay, so what did the rest of you do? All right, so I'm Dani. I'm a CTO of a company called Net Alpha Financial Systems. I'm not really into security. I do some pen testing and a lot of research on my free time. But this talk came, I met Mohsan, I think couple months ago, and we were talking about collaborating. In my company, we work a lot with the cloud, a lot of DevOps, a lot of trying to do security in the cloud. And then we said, all right, let's do something together. He's a pen tester, red teamer for a lot of time. He'll introduce himself.
Yeah, my name is Mohsan Farid. I break things, whether intentional or unintentional, but more often intentional. So I've been pen testing for quite some time. I did initially start off on the blue side, but the red side was a lot more fun. So once I pivoted over, I never looked back. But obviously there's a lot of synergy in between working together and collaborating between the red and blue side. So hopefully we're going to offer a lot of value to everyone here, whether you're red, blue, or management. So
yeah. So who works in the cloud? AWS, Azure, GCP? Great. So let's start with the share responsibility model, which basically tells you what's your responsibility when you use cloud providers and what's their responsibility. So anything related to physical networks, the servers themselves, the storage, hard drives, hypervisors, that's always their responsibility. If you're using IaaS, like AWS EC2, then you have to configure your virtual networks, which is like security groups, ACLs. The OS app is always yours, your data, and the people. When we move to something like a platform as a service, which is something like Fargate or Elastic Beanstalk, we don't take care of the OS, which is great. Take some things off your hand. You don't have to do patches. And then last one is a SaaS, something like Lambda functions, which you basically only write your small piece of code and you're good. So to get foothold in the cloud, we can use a lot of things, whether it's exposed machines, RDP, other vulnerabilities, regular web pen testing things to get RCE. SSRF, which is really, really common these days in clouds because you have the metadata server and its alternatives equivalents. In other clouds, the metadata server is from AWS. It holds everything related to your instance, its credentials. So using SSRF, if we can get that info, it's very useful for us. We're going to show an example of using, does anyone know what pickle bombs are in Python? Okay, so it's basically a deserialization attack, and we use that on a Redis server, which is exposed and by default does not have any off. And the app we're using has a Celery worker, which is just a regular scheduler. You can put things in queue, and it will do it in the background. So we're gonna listen for new messages that are coming to the queue and inject a malicious pickle. So let's see the demo. So we're starting off with a little script that will listen to the queue, find the message, block the queue, take the message, and inject our payload inside. Right here we can see that we got a reverse shell into the machine. And we're going to start playing with the metadata server and start getting some info out of it. So this is the startup script. Sometimes you get Git credentials if it's a CI/CD pipeline. But the more interesting thing that we're going to pull out of this is actually the access key, secret key, and the session token for our AWS machine. So we get the role. You can't see it, it's a bit small, but it's ECS instance role. And last, we're going to dump all the credentials. There we go. And we have the access key ID, secret key, and the token. This is a small piece of code that does this. If no one played with pickle bombs, it's literally one-liner. So next thing we're going to do is anyone working with service mesh, Istio console. All right, one person. So when everyone starts moving to that, it gives you a lot of easy configuration things that it gives you a lot of ease in life, basically, in networking and finding other services that your machines want to talk to, especially if you're in a microservice architecture. We're going to focus on console. It's probably, I think, the second most popular one after Istio. Istio is mostly used with Kubernetes. So what it does is basically gives you two things. It gives you a couple more, but the main ones are the service discovery. So you have a bunch of microservices. They can be different instances of the same service, and you're going to register them to a distributed key value store. It will store them, and you can do like DNS mask, and you'll basically access your services by DNS. And the second thing it can do is service mesh, which gives you identity and authorization. There's a console connect, which gives you a little proxy, sidecar proxy, which gives you secure connection between your services. This is what the dashboard looks like. You can see we got a Postgres service. We have a Sentry, Vault, and console service. And if you do a little dig query, we're going to do Postgres service.console. And you can see that we have two Postgres services. So we're going to poison them. There are two ways to poison them. Default configurations, if you look at the website, there's no auth token for registering services, so it's pretty easy. We're going to register a new service, call it Postgres, port 5432. And the health check is a pretty interesting thing. So you can do a health check with bin bash, which I'm not going to say it, but there's use your imagination. A lot of things you can do with that on every 10 seconds or 60 seconds as it's here. So once we do that, any service that wants to talk to Postgres it's like a round robin. It will hit the real server sometimes, it'll hit our server sometimes. And if you look at the Postgres auth handshake, there's interesting things you can do with it to dump credentials and downgrade SSL. I'm not going to go into it right now. You can talk to me after that if you want to know, but I'll show you a demo of how it works. And we do a console reload, which will basically gossip between the cluster and tell everyone, okay, we have a new service. Second thing, so here we use default credentials, which is, it's nice, but sometimes you have a problem because, all right, let's say someone did read the configuration and the advanced configuration, but a lot of people use something called registrator, which basically it's a container that lets you register services automatically inside your machine. So any new container comes up, you give it a service name, it will register it, and it will have a token with permissions to register a bunch of services. So let's say we got a shell on the host, we'll just run a new container with our malicious code, and it will register it automatically with the right token. We bypass that. So let's see a demo. So here we popped up our Python console. Here we can't see it, but I ran a proxy. This little bar on top is hiding it. And I'm going to try to connect to console postgres.service.console. And this is my little proxy, downgrade the connection and did some magic to dump credentials. And it's transparent, so the machine doesn't know anything about it. Next thing we're going to talk about is persistence. So here we dump some credentials. We got access to one machine. A lot of things that happen is sometimes developers forget dev keys or ops keys, or you get a CI/CD pipeline where you get environmental variables, you can get their access key. So a little clip, if anyone watches Zohan. Oh, no sound. Sorry about that.
Come up wherever you are.
So Lambda layers are basically like base images for Docker. If you know Lambdas, they're AWS's serverless functions. So a lot of developers use them to basically get a base layer with a bunch of libraries they need for all their functions, so they don't have to package them every time. So let's say we did get a dev key, or we got ops or a CI/CD pipeline role, so we can change layers. So I thought to myself, let's do something interesting. Most layers have a request library for Python, pretty common, everyone uses it. So how about I just patch it? I took a request library, did an override on the request call, and made it dump the credentials every time, and all the environmental variables, all the request, the JSON, the data, the parameters, headers, and send it to me every time. The interesting thing is it's versioned. So any new developer that will come in, he will always pick the latest version. It's very hard to find it unless there needs to be very good communication to actually discover this, because any developer will just, okay, requests layer, version 6, all right, latest version, probably someone like upgraded the version. It's pretty hard to find it. So we'll dump the data. We'll have a small listener that will listen for that request on our server, print it out nicely. And this is what the function looks like. You import the layer, you just import requests, and every request you will make will get some interesting keys. This can lead to privilege escalation. If a different function, someone creates a new function with other privileges and uses that layer, we'll get a new set of credentials with better privileges or other privileges. So let's see a demo of this. Here we're running our little listener, and we're gonna curl. You'll see it again. The thing is hiding it. We're just gonna curl our serverless function. You see the access key ID, secret key. This is one more time. So even if they expire about every 15 minutes, but even if they expire, every time it'll get called, we'll get a fresh one. So take this very seriously. There's a bunch of things that can go wrong, especially when it gives you very easy configuration, very easy way to do things, and developers love it, DevOps people love it, but it opens up a lot of holes. So I'm going to pass it to Mo, and he will talk to you about what we do when we reach the internal network and how we do that.
So, thank you. Can everyone hear me fine? Wonderful. So, effectively, we're just going to do a quick rundown of Active Directory. It's used to manage computers in, your traditional Windows environment. You could configure Active Directory with different protocols. LDAP is a primary one. So, for this attack scenario, we didn't want to, we thought it was too cheap or too easy to say, we popped a server with a vulnerable version of RDP on the outside. We wanted to, if you have a vulnerable version of RDP or any other service facing, external, you got bigger problems on your hands. So, our attack scenario on this actual test was going after ADFS. So ADFS basically, and I'm really dumbing it down, but making it really super simple. It allows you to have the ability for an organization to have their, let's say you have a SharePoint instance or an Exchange instance facing outside. You can now authenticate to AD on the inside without ever exposing your, let's say your domain controller or anything else. So it's used in traditional environments for single sign-on. And, pretty much you see it in a lot of organizations. So the vulnerability that we're using in this event to actually pivot to the internal network basically is on ADFS, which was detected by, it was a vulnerability identified by Preempt, which basically it allows an organization or an attacker to attack an organization by going after ADFS because it doesn't have, the extranet lockout policy does not apply to the organization. So effectively, I could sit here and, as an attacker, continue to run, dictionary attacks against your organization, and it doesn't lock out. It doesn't lock an organization out. So, I'm sitting here just either going after, every single account until I hit a right password, or the mitigation is actually just going to lock everyone out. So you're damned if you do and you're damned if you don't. And this is a legitimate concern. So, in this attack scenario, we're just basically guessing credentials until we hit one that's correct. And, we now have the ability to pivot. And, obviously your traditional pivoting methods would include, here we go. So
we're in.
So I guess a set of a pair of credentials that's correct. Now let's say I've done my due diligence and I've done some recon. I've got your VPN. And I now log in via VPN. You could also use leverage tools like Ruler, create malicious Outlook rules to basically pop a shell on a system, get a reverse shell flying back to you. So, you could also attack Citrix. The world is yours. Really, once you have a pair of working credentials, you can do pretty much what you want based on the, privilege rules of that user. So it makes it fairly easy to, take advantage of. So this vulnerability is something that still exists to this day. And, once we actually pivot to the internal, that's where the fun begins. So
we haven't seen like any mitigations in the wild for it, but basically if you're using any reverse proxy, you can just rate limit that endpoint. Mm-hmm. No idea why people don't do it, but we see it in the wild, and Mo can tell you that he does it in his pen tests and he always succeeds with it. So if you do use it, just 4 lines of code and you'll be safe from that.
Absolutely.
So Mo feels no pain. After I blocked him, he found different ways to bypass that.
So this is just the slides discussing what we did, the attack vectors that we can leverage in this scenario. And we're happy to share, additional details with anyone that's interested, along with tools and methodology. But once we're on the inside, what are we doing? So I don't like to be very noisy. We're going to basically talk about, your vulnerability scanner is lying to you. Whatever it's rating your, the vulnerabilities like SMB signing disabled, things like that. A lot of organizations go after, they patch their, MS-17, they patch the critical findings and they think, okay, I'm relatively safe. I don't have to worry about, simple things like null sessions, anonymous shares, or in the scenario that we're going to demonstrate SMB signing being disabled. But those are all very critical scenarios, especially when you start stringing these small, medium or low vulnerabilities together. You're actually going to have a really deadly attack chain. So I'm going to discuss some undetectable payloads using .NET, leveraging C2s, leveraging C3s, and even bypassing NTLM relay mitigations that are currently, people think that enabling SMB signing is going to help you. No, it's not. Enabling EPA is going to help you. No, it's not. Those are broken. So we're going to demonstrate ways of actually breaking into systems, even though they have, the recommended mitigations in place. So you hop in on the internal. Now you run responder in analyze mode. That's a great way to basically see what's happening on the network, and you're not. And when you're running responder in analyze mode, you're not responding back. You're just looking at what's happening. So a very simple scan I like to run when I hop on if I'm going to scan. One-liner, very simple. I'm looking for null sessions, SMB signing disabled, anonymous shares, and looking for servers that are active domain controllers, right? You run this on a very slow interval, not a lot of traffic, but gets you a lot of good low-hanging fruit. And typically in an organization, you'll find a null session box here and there. Why? Why is that important? Well, I can enumerate Active Directory with null sessions. I can find out all your users. Then I can guess, look at your lockout policy, do some simple password guesses, right? Stay below that threshold. Now, this is, null sessions is an info finding. It's not even anything that's really paid attention to. SMB signing disabled, if exploited correctly, you have system privileges, and you combine, something like responder or MITM6, DNS6 poisoning, you're going to have mass destruction. You're just going to start popping shells everywhere, like left and right. You're going to be flying, all over the place. Anonymous shares, I can upload malicious SCF files, have systems call back to me. Now I have your NTLM hashes, and then I can use that to crack. Or if I wanted to be really nasty with it, I could relay that back, authenticate to other systems. SMB RCEs, those are pretty self-explanatory. If I hop onto a pen test and I have SMB RCEs, my job is, what am I doing for the rest of the week? The kill chain is going to be pretty straightforward and easy. What we typically, this is a quick breakdown of what happens when you're doing a relay attack. I've discussed this a little bit. If there's any questions, feel free to ask me, after the talk or during the talk. Always feel free to raise a hand as well. I like to get the crowd to interact with me as well. So, effectively what happens, with a relay attack, well, you end up with system privileges. I don't need to pop 30 boxes. If I pop one, in an Active Directory environment, that's typically all you need. The rest is just a domino effect. We're not going to really dive into the kill chain post-exploitation process. This is more about getting the initial foothold. But if you do have any questions about what to do post-exploitation, feel free to ask. So currently, there's two issues right now that we have with the mitigations that are in place for SMB signing. The really, really intelligent people at Preempt identified a couple of vulnerabilities where effectively the mitigations that are in place for it with EPA enabling SMB signing, they're all broken. Right now, they're broken. And you could actually leverage NTLM Relay X, which is part of InPacket, to actually relay authentication attempts on the fly. So in this scenario, you're either using a responder or you're using MITM6 or whatever man-in-the-middle attack tool that you prefer to relay authentication attempts to different systems. Now, in a traditional relay attack, you're going after systems with SMB signing disabled. Now, it doesn't matter if SMB signing is enabled or not. You're still going to pop shells on them. So this was revealed at DEF CON and Black Hat this year. They called it the Drop the Mic report, exploit. Now, this has now been also the mitigations that Microsoft released for this, where the implementation was incorrect. So there's Drop the Mic Part 2, which was just released about a week ago. And so effectively what happens is all the mitigations that Microsoft has released as a result of the research done by Preempt, they're still invalid. So right now you could sit there and hop on an internal network and relay authentication attempts and just pop boxes every time a person with administrative privileges authenticates or elevated privileges authenticates. So it's devastating. It's catastrophic, really, because, if you're looking at your report from your blue team, an organization isn't too concerned about, SMB signing disabled. You still see it now, even though this is something that has been around for years, because there's a performance hit. Typically they don't enable SMB signing, but even now, if it's enabled, you're still going to get owned. So lots of stuff going on here. So you pop some systems on, you could use Durka John. He's a researcher over at Fox IT. The Priv Exchange attack, very, very useful attack vector to go from, popping a Exchange server and getting basically DA from there using DC sync, dumping, the domain controller. So let's quick rundown. Basically, what you're doing here with this also the printer bug vulnerability that he identified in the past, you couldn't relay authentication attempts to LDAP. Now, due to the research that was released by the Preempt team, I can take authentication attempts from SMB and hit LDAP. So what does that mean? I'm now able to pop your domain controller. That's a big problem, and this is because of the message integrity controls were not implemented correctly. The fix by Microsoft. So you are now able to pop a domain controller just by relaying authentication attempts, and you're just waiting until a privileged user authenticates, and it's all over. Now, how many organizations run their scan tools with elevated privileges? How many organizations run, their vulnerability scanner with domain admin privileges? It's just basically you're owning systems left and right. It's extremely, dangerous. So relaying SMB to LDAP, we've got two scenarios. You can connect via SMB to an Exchange server, and then you trigger the spool service bug. This was also a vulnerability dubbed as the Priv Exchange attack. Very, very useful. The other alternative is getting the Exchange server to authenticate to you and relaying the credentials back to a domain controller. So two different attack scenarios, highly effective, ends up in mass destruction. So this is just a quick breakdown of what I discussed. So this is one of the attack scenarios that I briefly discussed. I'm a big fan of Silent Trinity. Has anyone ever used it? So ByteBleeder, highly recommend following him. He's he's the guy behind CrackMap Exec, one of my favorite post-exploitation tools to use on a pen test. Silent Trinity is a C2 that basically lets you use different types of stagers. It's asynchronous, and it can be a lot of fun because one of my, in the past, PowerShell was like the big thing, right? Everyone used PowerShell. Empire had its heyday. It's slowly dying because of AMC. So now, the new PowerShell is using .NET. Using .NET payloads is one of my, it's almost too easy. I go against any type of endpoint product you can think of. You could throw different types of PowerShell payloads, and you could have to come up with like an AMC bypass, but PowerShell is being closely monitored this day and age, like now. It's much easier just to use .NET. Very few products are paying attention to .NET payloads. And my attack scenario, typically what I do is I do a relay. I host a, basically just a quick stager on a SMB server that's running on my box. And when someone with elevated privileges attempts to authenticate to their system, I just basically instruct them to pull my stager off my system, off of SMB with anonymous shares, so anyone can grab it. They grab my stager, they compile it with MS build. There's no binary being dropped, and it's executed with system privileges. So the shell that I get back is running a system. There's no binary, and it's all done in real time. So I run this attack within 30 seconds. I've got 60, 70 shells flying back at me in an organization. It's almost too easy. So it's it could be a lot of fun. So it's a great time,
That's how you feel after you pop 60, 70 shells?
Yeah, it feels like that.
He does that at home.
I do. So, ByteBleeder on Twitter. He's a great guy to follow. Lots of great tools. This is a quick setup of what my stager looks like here, my listener looks like. So, basically you're setting your stager configuration here. I'm using an MS build payload. So it's basically me running, it's a C# inline task, which is actually compiled and executed on the fly. And this is like a quick screenshot of me using, NTLM Relay X, which is part of InPacket, and along with, basically a quick instruction here, saying, right over here, basically executing a command over here that, all right, I want you to record all the relayed hashes here, target these systems, and disable my SMB server. And here's the command that I want you to execute. So they're running, over here, we're running MS build, and MS build is connecting back over SMB to collect to actually run my stager, right? So effectively over here, you can see, screenshots of me, any type of traffic that's, over here is going to be relayed to actually download my malicious, stager. So, and the rest kind of it happens automagically. So, what's happening in that process? Well, even if, let's say, for whatever reason, they don't have, some sort of product, it detects my payload, which hasn't happened yet, but even if that happens, they're still connecting back to me. So I'm providing them a known challenge right here, and I'm collecting their actual net NTLM hash, so I can still crock it. I have the challenge. I have their net NTLM hash. I can run a dictionary attack. So one way or another, I'm still getting something. Even if I don't get an actual shell, at the very least, I'm getting your hash. So now this is what happens when I run my little attack scenario. You can see all these different systems, grabbing my stager. And then over here, you're seeing all the systems here with system privileges. And basically I just got a whole bunch of shells just flying across from different subnets everywhere. So it's a really highly effective attack vector. And real world scenario, you don't really need this many shells, but it doesn't hurt. And that's what happens when I get 70 shells flying in less than a minute. So
yeah, cooking fish naked.
Absolutely. This is how I pen test. So so what happens, and then it was some of the reasons why I really like Silent Trinity, and it does support HTTP2. So a lot of products don't monitor HTTP2. So you have different channels that you can actually fire everything off of over. And then, if it's something like mini dump, which is amazing, let's say Mimikatz gets picked up, well, run Mimi dump. Like it's mini dump is amazing. You can dump LSAS and then pull in chunks the dump back over to your system, and then you can look for ClearDex credentials. So, there's different ways of doing it as well. You can, load your own, if you wanted to be old school, use proc dump to dump LSAS. There's 100,000 ways you could do this. And now the newest version does support Donut, so that's a whole nother level of fun that you can leverage. If I don't use this, if I don't use Silent Trinity, I highly recommend using Merlin as well. It's a great C2. That is, I believe it's written in Go, so you have the cross-platform awesomeness, and also HTTP2 is available, so you can still, grab everything, have your agent come back to your C2, and most products are completely oblivious to that. Post-exploitation, I've been using CrackMap Extreme as of late. It's very helpful. It does allow you to run Mimikatz on 2016 and other systems that were, supposed to thwart Mimikatz. This is basically done by, momentarily disabling Defender or basically instructing it to kind of like sleep for a little bit and then re-enabling it. Very useful and effective. You could basically deploy Mimikatz on a Class C in 30 or 40 seconds. So you just have clear text creds coming back to you. Very, very effective post-exploitation tool, which is basically a fork of CrackMap exec. So this is what we're seeing here. Mimikatz basically coming back, running on a 2012 server. We had to obfuscate, we had to blur this stuff out, but very, very useful attack vector, post-exploitation. So Mimikatz is great again.
You mean, huh? I have been using the things for thousands of years.
All right, so Mo showed you, I showed you the cloud stuff. When we do the simulation for the slides and looking for new techniques, we start with a cloud and an AD environment, either in a different cloud or on premise. And then we connect them and we try to do a pivot of getting in, whether it's proxying ADFS or using Ruler on OWA. Mm-hmm. And then we thought, all right, how do we protect and mitigate some of these things? So we can't change Microsoft code. So that's a bit of a problem. We did show that rate limiting part. So first thing, which I think is very important, is having all your infrastructure as code. So don't let developers go and manually change things. So this will actually prevent things like malicious layers, because once your infrastructure is as code, once you do you can use Terraform or CloudFormation. I use Terraform because it's basically cloud agnostic. You can use it in all clouds and gives you more flexibility. Sometimes it has new services in AWS before CloudFormation, which is AWS service, has it. And basically every time you do a plan or refresh, if it detects something is not the same, let's say I put a new version of a layer, it will check the hash of the files. If it's not the same as what was deployed last time, it will tell you that. So if you run that on a daily basis, even on an hourly basis, it takes less than a minute, you can get a lot of, it will basically block these things, and if you do apply, it will override that layer. Second thing is Packer. So following up on Terraform, which is basically having your infrastructure as code. This is another product from HashiCorp, which built Terraform. It's basically baking your base machine images, whether it's AMIs for AWS or the equivalents in other clouds. You can use Ansible scripts to run OS hardening. So it's basically automated. That way you don't really patch machines. Because when you start patching machines, you actually have to know what you patch. Sometimes patches fail. So building a base image, let's say there was a new update for your OS. So you build a new base image with that update, and you basically switch that in all the machines. Once there's a new image, once they pop up again, they will pop up with the new image automatically. So that way you don't have to follow what did you patch or is it patched. As long as you see that your new image is the base for all your machines, you'll be good. A lot of talks actually show some things about CloudTrail. So CloudTrail basically gives you an audit of all the operations happening inside your environment. And some other talks about attacking AWS show how you can tamper with logs or delete the logs. Tampering is basically, there's an anti-tamper in CloudTrail, which it has some checksum on the file. So if the file was tampered, it will basically say that it's not valid. But that doesn't help us because we do want to see what an attacker did in our system. So a very easy solution to that is having another AWS account. And there's a bucket policy to sync your CloudTrail logs with a new account. And it's a one-way sync. So it only drops it. It has encryption in transit. It will save it in your new account. That means even if someone has root credentials on your AWS account without audit logs, it won't be able to delete them from your new account. So they're safe that way, and you can do it in a regular interval. Secret management, we saw that we dumped some secrets. We have the Postgres, not a vulnerability, but basically that proxy that dumped the secrets. if you have hard-coded credentials, that'll be a problem because I'll grab those Postgres credentials and I'll use them as much as I want. So you can use either HashiCorp or you have AWS HashiCorp Vault or AWS SSM for secret management. I like HashiCorp because it gives you more flexibility. It can make new credentials for, let's say, for your databases, for MySQL, for Postgres. It'll make short-lived credentials and let's say a 15-minute. And then when your app tries to access it again and gets permission denied, it will just ask Vault for a new set of credentials. And that way, even if someone did dump your credentials, they'll be valid for a limited amount of time. Inter-service communication, you can put sidecars on all your services, whether it's a Console Connect, you have Envoy sidecars or other proxies that can do mutual TLS between them. So it'll be harder to basically sniff the traffic like something we did with Postgres. WAF, you have AWS WAF, not a fan of the pricing policy because you pay by the rule. So I use Naxi with Nginx. It's a pretty nice WAF. It has this like feedback loop where you deploy it, you put it in learning mode, and then you have an Elasticsearch DB, which will have all the things that it would have blocked. So you run your app and you see what it would have blocked. And there's a nice little tool that will generate rules based on what you say, all right, this is valid, so don't block this, or this is invalid, this is an attack. So block that. And it's super fast. It's super slim. If you put it like an Alpine Docker image, it'll work super fast. And for AWS, you have GuardDuty, which is it's pretty cool actually. It continuously monitors things, your CloudTrail logs, uses some machine learning to detect things that it can flag them as like critical or info. It has a bit of a lag, so it might flag things after it already happened, but then you can go and do the instant response and go look at your audit logs and see what happened, revoke the credentials that were stolen, and basically do your IR. And you have Inspector, which will scan all your machines on AWS. It can do it automatically, weekly, daily. Compare that to the new CVE list and tell you what you need to patch. And so you can bake a new image and deploy them. So we're done. We have some time for questions. Any questions?
Thank you.
Thank you.
Thank you for coming.
And now, yes, please. Questions? Yes, we have one, of course, at the back of the room.
Hi. I was asking myself if a ruler, because you told that ruler is one of your standard tools, is still working for code execution, because I thought that was patched by Microsoft.
It was, yes. So Ruler was basically one of the tools that we used to use. If you're going against an older version of, let's say an organization that's running outdated tools, then you could leverage Ruler. Ideally for me now in an actual pen testing scenario, I'm looking for something along the likes of finding a VPN that I can authenticate to, going after Citrix instances, things like that, some things of that nature. But I would never rule it out as rule it out as an attack vector, just in the event that it could actually still be leveraged.
Okay, I see. Maybe one more question. You mentioned a CrackMap exec fork, but I didn't understand how it's called.
It's CrackMap exec. So CrackMap exec is the original version.
Yep.
Extreme. So CrackMap Extreme is the fork that was done by, I believe his Twitter handle is AMS Hacks. But if you just hop on GitHub and look for CrackMap Extreme, it's basically a fork of CrackMap exec with all the new additional functionality.
Okay, thank you. Awesome.
Sure thing.
Any other question? Yeah.
About the secret management tools, do you know Mozilla SOPs and do you use it?
No, I only have experience with AWS SSM for secret management or Vault. Honestly, I don't want to use anything other than Vault right now. It gives me a lot of flexibility. I can write my own modules for it. And it's a huge community. So it updates on a weekly basis, if not on a daily basis.
Any other question? Okay. Then thank you again.
Thank you. Thank you for coming.
everyone.
I got a bottle for you.